For number 49, we're asked for the domain of the function at the right. The domain refers to the x values, so we're going to consider left to right. Left to right, the points on the graph start at -2 and extend to the right of it. So that would be x is greater than or equal to -2. For number 50, we're looking for the range, where range refers to the y values. So the highest point on the y-axis that the graph goes to is +4. All the rest of the points are down below and extend infinitely in that direction. So that means that the range for this function is y is, not greater than, but smaller than or equal to 4. Because all the y values are below or at y equals 4. For each of these, we're going to give the domain and the range. So the domain is the allowable x values, and you'll notice that this graph has no break from left to right and extends infinitely in both directions. So that means its domain is all real numbers. And now let's take a look at the range. This graph extends with no break from down to up and extends infinitely in both directions, so that means its range is also all real numbers. For number 52, the domain is the values of x, which extend from -2 to 4, so the domain is -2 is less than or equal to x is less than or equal to 4, and the range is the set of all y values, so the y's extend from -1 up to 4, so the range is -1 is less than or equal to y, which is less than or equal to not 4, but rather 3. 4 is marked up there, but the highest point is actually at 3. For number 53, we are asked which of these represent a function of x. We can use the vertical line test. Any vertical line that intersects this graph will intersect in only one point at a time. Any vertical line that intersects the next graph also at one point at a time. So that means that both of these are functions. In 3, a vertical line can intersect this circle in 2 places, so that means this one is not a function. In number 4, a vertical line can intersect only one point at a time, so that one is a function. For number 5, a vertical line will intersect this at one point at a time. However, it can be tempting to think that a vertical line will intersect in 2 places when we go through x equals -1. However, there's an open circle on one part of the graph and a closed circle on the other, so that really doesn't represent 2 points. So that one is a function. Number 6, however, is not a function because we intersect 2 points at one time. So our functions are 1, 2, 4, and 5. 1, 2, 4, and 5 only. For number 54, we're asked which point is on the graph. For a point to be on the graph, the x and y value have to make the equation a true statement. They have to be a solution. When we graph a line, we're literally graphing all of the solutions in the form of ordered pairs of this equation. So let's try replacing x with 1 and y with 7. 7 is equal to -2 times 1 plus 5. That would give us 7 is equal to -2 plus 5. -2 plus 5 is 3, so that is not true. That point's not on the graph. All right, let's check out b. For b, we are replacing the x value with 3 and the y value with 1. 1 is equal to -6 plus 5. -6 plus 5 is -1, so that one's not true. We can get rid of those 2 choices. Now let's try the answer choice for C. When x is -3, the y value is equal to 1. Negative 2 times negative 3 plus 5. That would be 6 plus 5 is 11, not 1. That doesn't work either. Let's try 1 comma negative 3. So if x is 1, does that make y equal to negative 3? And so that would give us negative 3 is equal to negative 2 plus 5. That would give us 3 is equal to negative 3. That one doesn't work either. And of course, it's our last answer choice here, which we think is going to work. So let's replace the y with 3 and the x with 1, and that's going to give us 3 is equal to 3. So the choice E is correct. In number 55, the point x comma 4 is on the graph of 3x minus 2y equals 7. What is the value of x? So we can replace the y with 4 and then just solve for x. 3x minus 8 is equal to 7. Adding 8, 3x is equal to 15, and x is 5. In number 56, we are looking for the ordered pair that represents the x-intercept. If you think about what constitutes an x-intercepts are points that are on the x-axis. All of those points have a y value, or a y-coordinate, of 0. So what that means is we can just take this equation right here and replace the y-coordinate with 0 and solve this for x. So 5x is equal to negative 20, and x is equal to negative 4. Therefore, the ordered pair is x equals negative 4 comma y equals 0. Similarly, in 57, we are looking for the ordered pair that represents the y-intercept. The y-intercept has an x value of 0. So replace the x with 0 in this equation and solve for y. So 0 minus 4y is equal to 12, or negative 4y is equal to 12, and dividing by negative 4, that gives us y is equal to negative 3. So the y-intercept is the point 0 comma negative 3. In 58, we are finding the slope of the line. Slope is rise over run. Rise is the subtraction of the y values, and run is the subtraction of the x values. It doesn't matter the order that you subtract in as long as you do it consistently. Let's subtract those y values first, 3 minus 1, and then subtract the x values next. That would be 2 minus 8. Remember to do it in the same order. 2 and 3 were in the second point, so I use them first in each of the subtractions. We can do it in the other order, but we just need to be consistent. 3 minus 1 is 2. 2 minus 8 is negative 6. And so that gives us a slope of negative 1/3. Now we're going to find the slope of another pair of points. And so that will be the subtraction of the y values, 3 minus negative 1, divided by the subtraction of the x values, 3 minus 3. That would give us 4 divided by 0, which is an undefined value. For 60, we're asked for the slope of the line given its equation in standard form. In order to find the slope, it's easiest if we just move the equation into slope-intercept form. So I'm going to subtract 3x from both sides, and then divide both sides, or all terms, by negative 7. That will give us y is equal to 3/7 x minus 2, and so that means that the slope is positive 3/7. For number 61, we are looking for the equation of a line with slope passing through the point negative 2 comma 1. We're going to use the point slope form of the equation of a line here. So y minus y1 is equal to m times x minus x1. y1 is the y value of the point, m is the slope, and x1 is the x value of the point, and x minus negative 2 is the same as x plus 2. So y minus 1 is equal to 3 times x plus 2. In number 62, we're looking for an equation in standard form. Standard form has no fractions, so I'm going to multiply all terms here by 7. 7 times y is equal to 3 times x plus 5. and then subtract the 3x from both sides. Now we have negative 3x plus 7y is equal to 5. In order to move this into standard form, I need to multiply all terms by negative 1 so that the first coefficient is not a negative number. So 3x minus 7y is equal to negative 5 is the correct answer. Now let's take a look at number 63. We have numerous answer choices on this one, and we are looking for the equation of this line. So if it's in y equals mx plus b form, we are looking for the slope. This is a falling line with a rise of negative 3 and a run of 2 as we go from one point to the next. So that means that our slope is negative 3 divided by 2, and then the y-intercept b is positive 3. So y is equal to negative 3 halves x plus 3 is the correct answer. Last exercise on this page, which graph represents x equals 3? X equals 3 is a vertical line where all the x coordinates of the points on the line are 3. Notice that every single point, if you name the coordinates, would have an x value of 3. So that's choice D.